So we looked at inverses in the first unit, and I told you inverses would be something we would see in later units. For rationals, all rationals have an inverse that is also a rational function. So if they gave me f of x is 3x plus 1 over x minus 5, and they want me to find the inverse, remember this is just notation for inverse, then it starts off just like our inverse problems in unit 1. Okay, we're going to do x equals 3y plus 1 over y minus 5. So the first step is still just to switch x and y. Now, anytime we're dealing with fractions in our equation, we want to try to get rid of the denominator. So what you want to do is multiply both sides by the denominator. So that looks like this. X times y minus 5 is equal to 3y plus 1. And I see that I have a y on both sides, and the goal is to get y by itself. So I need to get rid of these parentheses. I need to distribute next. So x times y minus 5x is equal to 3y plus 1. And then we look at it, we have two terms with a y and two terms that do not have a y. So it does not matter here if you choose to move these two terms to the left or these two terms to the right. I'm going to move my terms with y to the left since we normally see y equals on the left, but it doesn't matter. So I'm going to leave xy alone, and I'm going to move 3y over by subtracting it. And I'm going to leave 1 on this side, and I'm going to move 5x over because it does not have a y. And so I'm going to add 5x. So I've just moved a couple terms to the other side. And then the reason we wanted to get the y's on the same side is so that we can actually factor y out. Y is the GCF right now of xy and 3y. So if we factor it out, then we're left with x minus 3. And what that allows us to do is divide by x minus 3 and get y by itself. So y is equal to 1 plus 5x over x minus 3. And you also could see that as inverse notation. And you can see that every time with rationals because all rationals, like I said, all of their inverses are functions. So you could see this notation for all of them.